everyone. Welcome to today's Germination Retail Roundtable webinar. We're exploring the world of midge-tolerant wheat and how you can safeguard this valuable technology. My name is Mark Zinkowitz, and I serve as editor for Germination, and today I'm happy to be your host. Before we begin, I'd like to thank our three sponsors, 2020 Seed Labs, Cantera Seeds, and SeCan for their support. We'll be doing some live tweeting during the proceedings. I encourage you to engage with us on Twitter by following the hashtag #SeedRetail as we go along. During the webinar, you may have some questions for our speakers. Please feel free to type these right into the chat box on the bottom left side of your screen at any time during the webinar, and we'll address them during the Q&A session that we'll hold after each speaker, we'll have a Q&A session at the very end of our webinar today after both our speakers are finished talking. Also, the webinar is being recorded and will be available at germination.ca following the event. I'd like to introduce the first of our two speakers today. Santosh Kumar is a wheat breeder at AAFC in Brandon, Manitoba. His projects include investigating new sources of resistance to wheat midge. He's also a professor at the University of Brandon and secretary for the Prairie Recommending Committee for Wheat, Rye, and Triticale. Santosh, the floor is yours.
Thank you, Mark, for the kind introduction. Good morning, everyone. I'm a wheat breeder at the Brandon Research and Development Center, and my primary duties are to develop premium quality wheat lines for the farmers of Canada, especially the eastern prairies. One of my objectives is to breed for midge-tolerant varieties. And I would just like to talk a little bit about the wheat midge itself first before going into the variety development aspect of it. What you see in the picture on your left is a wheat spike, and you can see the orange-colored midge insects on it. They are the size of mosquitoes, and they can cause severe yield losses and grade losses to the wheat that the grain farmers produce. The life cycle of wheat midge is quite complicated, and it involves an adult insect that you see in the picture on the left. This adult insect lays about 70 to 80 eggs per female during the months of June and July, and those eggs stay at that stage for 6 to 7 days, and then they turn into a larva. Those larvae feed onto the kernels, and that's what actually causes the damage. The insect itself doesn't cause the damage, the larva does. So the number of insects leads to the number of eggs, leads to the number of larvae, and that's where we have to control the insect itself. The larva then goes into a hibernation phase as a pupa in the soil, and then next year, when the conditions are good, it comes back up and becomes an adult fly and lays eggs again. So that's the life cycle of the insect. In the picture top right, you will see larvae feeding on the kernels. 3 to 4 larvae are enough to cause significant damage on the wheat spikes, but there can be as many as 26 larvae feeding on those grains at any point of time. So depending upon the infestation, you may not have any grain left in the spikes if the infestation is very severe. The picture on the right bottom just compares the wheat midge on the right hand side in that image to another insect which is orange in color but bigger in size, which are called the legsonids. And we should not be confusing the midge when you are scouting. That's why I put the picture up that legsonids are different from wheat midge and do not cause damage on the kernels. This year was a warm, dry year, so you can see that there was a severe infestation of midge around Winnipeg and Brandon, but everywhere else there was some level of midge. So none of the prairie provinces are actually less prone to midge. They are all having lots of infestation. In some places it's very severe, like Brandon, and we always see that year after year. But in some locations it can be less, it can be more, but we have this problem. In fact, the wheat midge is a problem all over the world wherever wheat is grown. So we have to constantly breed for varieties that have resistance to wheat midge and can be grown anywhere in the prairies. Moving on to the variety development aspect of things, how we breed for midge tolerant lines. In the picture on your top left, you see 3 Petri plates with seeds in it. And if I can use the mouse, this is a variety called Roblin, which is susceptible to midge. And you can see the grains are nice. They're not as bold, but that's the trait of the variety. But they are nice and very easily graded as number 1. On your left over here, you see same variety Roblin, but with some damage in the seed. Still harvestable, they'll come out of the combine as whole seed. Whereas on the right over here, same variety but lots of damage due to midge, and they look something similar to this under the microscope. So there is literally nothing left in the seed, and they have secondary infection. You see the black spots around on the seed, which causes major yield losses, and whatever grain is left is downgraded, so you don't get the good price for the crop. During the variety development, when we are screening for midge tolerant lines, each spike from the lines are investigated. They are dissected under a stereo microscope, and each kernel is investigated. Kernel by kernel, the person looking at the infestation is moving up the spike, and as soon as he finds the susceptible spike or he finds the larva or remains of the larva on the seed with some damage on the seed, they call the line susceptible. We don't necessarily discard this line or discount this line because it can still have very good attributes and still become a variety, but this will be called a susceptible variety. Over here, this is another shot of directly showing you the damage due to wheat midge and presence of the scales of the larva on the spike itself. The image in the middle here is showing you a cocoon of the midge that actually falls to the ground and hibernates. That's how it overwinters and becomes a problem next year. So during that variety development, those lines that have very good attributes are either selected for midge tolerance or are considered midge susceptible but become varieties. We actively do this in our breeding programs. However, we have another component of our research where we actively look for another factors or genes that cause resistance to wheat midge or provide some level of resistance due to other mechanisms, such as having volatile compounds in the spike where the wheat midge doesn't want to feed on those kernels. So over here you see a population of different germplasm. Some are wild races, some are very old lines, some are very newer lines that have become varieties. And we are actively looking at this germplasm to figure out what is the source of resistance in them. Can we find something different from SM1 gene that we currently have for midge tolerance? By the way, fun fact, the SM gene that provides tolerance to wheat midge comes from the name of the wheat midge, Pseudodiplopsis mesolena, and SM1 is derived from that name itself. Currently, we only have SM1 as the major source of resistance. As of today, we don't have any other source of resistance. So there is really no plan B. We have to maintain this gene, protect this gene, so that the insect doesn't become resistant to this gene. That's a very clear message I want to say, that as of today, we don't have plan B. We have lots of different leads we are following, but we don't have a plan B as of today. Moving on to something that you want to hear more is what do we have in the pipeline and what has come up recently in terms of wheat midge resistant lines. The lines that are highlighted in bold are the lines that have come up out of our program, and you may be familiar with some of them. Shaw VB has the best resistance to wheat midge, and we are trying to understand why this line, compared to all the other resistance lines, has better resistance to wheat midge. And that may lead us to figuring out what else can we do to provide better resistance. New lines that have come from our program are AAC Warmament, which is listed at the bottom. That came out last year, and it's a very good line with FHB tolerance and midge resistance, and it's marketed through SeCan. Leroy came out this year, and again, this is a good line. Shorter, has very good fusarium resistance, and is also resistant to wheat midge. So these are some of the new germplasm that have come from our program that you may be interested in the future. And once these varieties are produced, we provide the breeder seed to different seed companies, and they take over the job of multiplying it and taking it to the certified seed level, and all the policies related to implementation of all the policies related to midge stewardship. So with that, I pass on the presentation to Todd, and please feel free to ask questions if you have any. Thank you very much.
Thank you so much, Santosh. Again, if you have questions for Santosh, please type them into the chat box and we will address them at the end of our webinar. I'm just going to quickly introduce Todd before he begins. Todd is Business Manager, Western Canada for SeCan. His love of agriculture started in childhood, being raised on a mixed grain and beef farm in Grandview, Manitoba. He continued his journey in agriculture when he started his career in 1990 in the seed industry, first at Proven Seed and at SeCan now. He's also the president of the Canadian Seed Trade Association. Todd, the floor is yours.
Thanks, Mark. So over the next 30 minutes, maybe 35, I will go through a little bit of background, cover some of the things that Santosh already talked about from a stewardship level, and then want to spend the back half of the presentation talking about production and processing and working with the midge-tolerant blends. And so, give you a little bit of background. I'll try and breeze through any of the material that Santosh has covered already, and then spend more time on some newer material. And so, Santosh already talked about the spread of the pest. And I've used this number now for coming on 10 years, is this estimated $36 per acre. But I wanted everybody to understand where that comes from. And it's based on the economic threshold of the midge, and using a 40 bushel per acre and a $6 per bushel wheat. So that's essentially where the number comes from. So it's a pretty modest number, and you can see under higher pressures where that value of the producer expands dramatically. We've also seen a drop in the overall pressure since the introduction of midge-tolerant wheat in 2010. And I attribute part of that to reduction in pesticide applications. So the beneficial wasps are able to do their job, keep the pests at bay, and allow the midge-tolerant to do the rest. And so it's a very sustainable system that provides great value to producers, has an environmental benefit, and allows wheat to be grown in rotation on a normal part of the farming practice. There were parts of the prairies that had abandoned wheat in the 1980s because of midge pressure. And so great steps forward, and now we're seeing the plant breeders like Santosh and the others putting all of these traits into one package. So they've got midge tolerance, they're adding improved fusarium tolerance, shorter, stronger straw. So all of these things coming together so that you're not having to give up one trait to get another. So all that to say that it's an important trait that just adds value across the board, and we want to do what we can to protect it. So Santosh talked briefly about the life cycle of the disease, and it's the protection occurs when the insect when the larvae starts to feed on the kernel. It triggers a reaction in the plant, a phenolic compound's released and turns the insect off feeding, or the larvae off feeding, and rather than feed, they choose to starve to death. And so there's always this small bite in the kernel, and so there is a little bit of damage, but it doesn't consume the entire kernel, and it's preserved as part of the overall volume in the harvestable grain, as well as reducing the overall impact on quality. So there is a little bit of feeding. We use tolerant rather than resistant because of that first bite that insect has to take in order to be turned off of the feeding. The tolerance is based on a single gene, the SM1 that Santosh mentioned, and based on previous models, the insect tolerance in a single gene resistance breaks down quite quickly. And so very early on in this process, plant breeders and entomologists determined that there had to be something else done to ensure that the midge tolerance was preserved past the 10 years that was estimated it would last without having some form of stewardship. And so what was developed was an interspersed refuge. That means that two varieties are planted together. In this particular case, 90% of the varieties being tolerant, 10% being a susceptible refuge. I'm going to just click a video here, and I'm going to explain a little bit about the refuge. We're going to play two quick videos for you right now.
The Stewardship Agreement for Midge Tolerant Wheat limits the use of farm-saved seed to one generation past certified seed. It's a simple step that keeps the interspersed refuge system at the proper level, preventing buildup of resistant midge. So how does midge tolerance develop? Without a proper refuge system, the field is planted with just a single variety of midge tolerant wheat. In a natural wheat midge population, the majority of midge are non-virulent or susceptible to the midge tolerance gene. However, a small number will be naturally virulent, resistant to this technology. As midge larvae start feeding on the developing wheat kernels, only these virulent midge survive. As adults, the virulent midge would mate only with each other. A large virulent population quickly builds and feeds on the midge tolerant varieties. Without proper refuge, midge tolerance could break down within 10 years. Limit the use of farm-saved seed to one generation past certified seed. It's a simple step that protects the one and only tolerant gene. The Stewardship Agreement for Midge Tolerant Wheat limits the use of farm-saved seed to one generation past certified seed. It's a simple step that keeps the interspersed refuge system at the proper level, preventing buildup of resistant midge. So what is an interspersed refuge system? With an interspersed refuge system, 10% of the plants are a susceptible variety of wheat. As the natural population of non-virulent midge larvae and virulent resistant midge larvae feed on the wheat kernels, some non-virulent midge will survive on the 10% susceptible plants. As adults, the non-virulent midge would intermate with the virulent midge. The offspring of this cross would be non-virulent, since non-virulence is the dominant trait. This prevents a buildup of a large virulent midge population and could extend the life of midge tolerance to 90 years or longer. Limit the use of farm-saved seed to one generation past certified seed. It's a simple step that protects the one and only tolerant gene.
All right, right. So, yeah, to ensure that that 10% remains in balance, there's a stewardship system that has been put in place, and we've been working with it now for 10 years. And it helps ensure that those virulent midge at a very low level mate with non-virulent midge, and some of that population is preserved in the population, and that the models show that this could preserve midge tolerance for 90 years rather than the predicted 10. So it's an important piece of our plan to keep the SM1 gene viable for a long period of time. So with every purchase of midge tolerant wheat and every the production that goes on in the fields, farmers are required to sign a stewardship agreement, and this ensures that farmers will maintain the interspersed refuge system. There's only, as Santosh said, there's only one gene. It took 15 years to develop, and we're incorporating it into more and more products, so it's important that it is preserved. The stewardship agreement, up until recently, was a paper copy that was signed every year by the retailer and their customers. Starting in 2018, we moved to an evergreen agreement, and our midge tolerant wheat assurance site that allows retailers to sign an agreement once with their customer, and then it's logged in the system, and then they only have to add additional purchases. So essentially it adds great convenience for the retailer as well as the farmer customers, and avoids having paper copies float around and paper copies being lost. So it's a much more efficient system, but the nuts and the bolts of the system are the same as what we've used in the past. The requirements are the acknowledgement that the seed contains the refuge variety, acknowledgement that the SM1 is the only gene for midge tolerance, and that limiting the use of farm-saved seed of one generation past certified is necessary to preserve the longevity of the SM1. I have a couple screenshots of the stewardship agreement that is online with our stewardship assurance site. And so once again, it's very similar to what we had in paper copy. Has some background material, representations and acknowledgments that I went over, and there's toggles on the screen at several places just to allow the signer to acknowledge in more than one place that they've read. And it's not overly onerous. There's essentially 3 things that they need to keep in mind. That is, they agree not to use farm-saved seed for more than one generation past certified. They understand that the varieties comply with, they understand that they will comply with plant breeders' rights, and I believe all of the products to date have plant breeders' rights as an extra level of protection. And they may be audited for compliance, including inspection and sampling. And that's a process that's been ongoing the last 2 seasons as we follow up with past purchasers, and we've had very positive feedback from those that have been audited because they believe in the technology and they want to ensure that it's there for future generations. So I'm going to shift gears now and talk a little bit more about what it takes to get that product from a breeder's hands through production, processing, and essentially down to the point where it can be sold as certified seed. So I'm going to talk a little bit about the additional certification requirements, the refuge percentage, some thoughts on managing it in the field, cleaning, the testing and submission of Form 182 to CSGA, how do you remediate, and eventually crop certificates and tags. And so hopefully there may be some questions on this, but we'll try our best to answer those at the end. So part of the stewardship requirements that breeders have put in place are this additional certification requirements, and we've worked very closely with Canadian Seed Growers Association to ensure that this remains in place. And so essentially the breeder assigns additional certification requirements at the time of variety registration, and then we rely on the CSGA to enact that. And so the step that is in here is the test that shows that the required refuge is in the product at the final stage of certification. So that's the test, and then the completing of the declaration, which is Form 182 for CSGA. So the breeder chooses the refuge for their variety based on a number of considerations, and we've worked with Santosh and talked to him about these in the past. And the things that they keep in mind is, first of all, it has to be a non-SM1 variety, so it has to be not tolerant to midge. Try to find something that's similar in maturity so that it matures at about the same time, and you want it to be the same class of wheat. Similar height or shorter. The ideal would be exactly the same height. You don't want it much taller because they're sticking out and we don't want them rogued out of the sample. You want a similar seed size so that they remain in balance at the cleaning and harvesting process. And then you also want a product that's widely available to the distributor so that if remediation is required, that that seed is available. And so it's not always easy to find the right product, and one of the biggest challenges is making sure that as you're launching a new midge-tolerant variety, that stock seed of your refuge is going to be available. And sometimes you pick a product that's popular, but in the 3 years of ramping up a new midge-tolerant variety, it may start to drop away. So it does create some unique challenges on its own. Because the varieties aren't genetically identical, there's going to be differences that happen in the field, and I call this drift away from the refuge. You're originally targeting 10%, and when the breeder seed is added, it is at that 10% level. But that can move. It can move up and it can move down for a range of reasons. The most obvious ones are midge damage, feeding on the midge and reducing the percentage of refuge over time. That's the most obvious. Subtle differences in disease resistance may limit the production of one variety over the other, or may encourage greater yields. There may be shattering differences, slight maturity differences, pure agronomic performance. One variety clicks in a particular year, and then seed size, which may happen even though you try to minimize that. So that can skew the varieties one way or another. To try and minimize drift in the field, I know this one throws people off a little bit, was when you spray for midge, but at a production stage, if you had severe pressure and wanted to ensure that your midge tolerant variety was not your refuge was not being fed upon heavily, and one of the steps you could take is to actually spray for midge to reduce that impact and ensure that you're not having to blend as frequently. So just one of the tools you could use. Managing diseases, which is always a good agronomic practice, the use of in-crop fungicides to ensure that the crop is clean and healthy as possible, and then watching harvesting, timing, and swathing to ensure that there is no shattering, to make sure that the subtle differences in maturity are not being expanded and causing differences when the crop is being harvested, put in the bin. So once the crop has been harvested, it's important to submit a clean sample to a recognized lab as quickly as possible to determine what you're dealing with. And so currently there are 3 labs that offer the service: Discovery Seed Lab, Sask Research Council, or SRC, and then BioVision SGS offer the service. And I always suggest having a test before and after cleaning. I know this adds additional cost, but it gives you an idea of what you're dealing with. And there are different levels of tests. So even if you were to test at a certified level, which is only 200 seeds, it's $115, and that lets you have some idea of what you're dealing with. In terms of submitting a cleaned sample, many seed growers will hand screen a sample to mimic what they are doing in their plant. It's important this is fine, but it's also important to do a test afterwards, particularly because it may skew what they're planting and growing subsequent years. So if you've cleaned out much of your refuge accidentally, you may have a severe drop in refuge going forward. So when you're testing for a refuge, every lab must develop their own unique test for every varietal blend. Unfortunately, at this point in time, it's not as simple as, yes, there's 90% tolerant variety, 10% refuge. It doesn't work that way yet. We're working so that in the future there is an SM1 test that could be used by all labs, and just be able to submit your blend and say, yes, it's in range. But right now, every varietal blend has a unique test that must be developed for every pair to ensure that the varieties can be told apart. And so it's a SNP marker that is used to determine what each of the varieties look like in their profile, and then they can be measured to ensure that the appropriate percentage is in the blend. So I'm not sure if that all made sense, but it's not as simple as just saying yes or no, this has SM1. Each blend has a specific test for it, and if another variety was to creep into that blend accidentally, or if there was a sampling error, it can completely throw the results off, because that whatever contaminant might be in there might look like one or the other varieties. So it is a complex process. The refuge percentages vary depending on the number of seeds tested, and so this is essentially sampling error. At the certified level, 200 seeds are tested. And you think about that, if you have one seed, or say 2 seeds that either fall in or fall out of the sample, that's 1 whole %, and that can move you in or out of the range. And so certified level is the lowest confidence level, because there are only 200 seeds tested, and for that reason, the refuge allowable range is the widest. So from 5.2 to 16%. As you move up the classes to the higher pedigrees, more seeds are tested to ensure greater accuracy, and that tightens up the range. And so with that, the more seeds you test, the cost of the sample increases, just because more work for the labs. And so I pulled this information from the SRC website, so I'm not sure what the other labs' costs are, but this one was pulled from SRC earlier this summer. And for 200 seeds, it's $115, registered $200, foundation $200, and then select is quite costly at $450. So there is a real cost here, but it does provide the starting point in ensuring that refuge is there. It kind of reinforces the point that it's important to work with larger lots and ensure that you're doing accurate sampling to ensure that the results are going to be accurate. I have a couple of just shots. This is from one of our seed growers who was working with SRC. It has the grower information blacked out, has the varietal blend, Carberry and Jathari in this case, the pedigreed seed class, the acres, the crop year, and then it lists the test results with tolerant seeds and the refuge seeds in the blend. Another sample, the first one was in range for certified, and this particular one is not in range. And so this one is, you can see that it's 4.8, and whereas the tolerant seeds are 95.2. And in this particular case, I always recommend a second test, and I'll talk about that in a little bit in terms of how and why to remediate. This is Form 182. Once you have your successful midge tolerant sample test, you would fill out this declaration and submit it to CSGA to complete the final step of the certification of your seed lot. So I mentioned why 2 tests. And so when you're only testing 200 seeds, there's a great chance for sampling error. And if you could do a $115 test to determine whether or not you're way out to lunch, you may be able to tweak your cleaning process to try and get you closer. So if you understand that there are subtle differences about the 2 varieties in the blend, seed size, maybe one might be slightly larger, one might be slightly, maybe the refuge is bigger, but you can adjust your cleaning process to move it up or down ever so slightly to try and bring it back into range if you need to. The other thing you could possibly do is, I lost my train of thought on that one. So you can tweak those settings to try and adjust for seed size, and you don't want to inadvertently clean something out if you didn't have to. And I always recommend the second test after cleaning to get the final results, and that helps ensure that what's going out to the customer is proper, as well as what you're growing on your own farm remains in balance. Because if you were inadvertently to clean out the refuge during the process, that would that would show up in results much later when volumes are higher and potentially result in remediation being required. So if you do find that your refuge is out of range, there are a few things you can do. One is to drop it to a lower class, and so if you were testing at, you could always drop it to certified or registered if you didn't necessarily need the stock seed, and sell it that way. If you did have to remediate, the first step is test again, just to make sure. And so I know this is adding to additional testing costs, but you really want to be sure that the refuge is where it is before you start embarking on remediation, because once you go there, it's not easy to change that, and you've invested a lot of time and cost. So having the 2 points reassuring you that the results were accurate and that the sampling was good. We will be providing some slides on proper sampling process at some point in the very near future. Sampling is so important in this process when you're working with such a small number of seeds, and I've seen some of the samples that have made their way into the lab. Sometimes they've been maybe harvested a little too tough and stored in plastic, and it's not, we don't want to go there. We want to make sure that proper samples are drawn and then stored properly and submitted to the lab to ensure the most accurate process. So remember that if you're only testing 200 seeds and 2 seeds is 1%, so make sure that sampling is done well. And we'll try and post those sampling techniques in the very near future. So with remediation, there are no easy fixes if your refuge is too high. There's really no pure product that would be available. So the best option is to blend with a lower refuge lot. If you have a friend, neighbor that has a lower refuge lot, you could blend the two together and reduce the refuge that way. Maybe solve two people's problems if one is low and one is high. You can demote to a lower class. That always works. Or in the case of own use, we have done this with seed growers who have too high of refuge, is to work with CSGA to allow own use, because you're not harming the varietal blend in this particular case, or there's no risk to the SM1, to allow it to be grown in the hope that the refuge will drop and the tolerant variety will increase in blend and bring it more into balance before it's actually sold to farmer customers. So remediating at a high level, not easy. When refuge is too low, and this one does occur more frequently than high, we have a blend calculator that allows you to determine the amount of refuge to add. And when we post the video, we'll post this blend calculator that you can use, and it helps provide accurate calculations to ensure that you're adding the proper amount of refuge. And when you're sourcing refuge, you want to ensure that it's the equal pedigree class that you're adding. It's the lowest common denominator is what gets applied as a class to that particular product. So if you're working with foundation of your tolerant variety and have to add refuge, you want it to be foundation of the refuge as well. And I can never say this enough, don't try to top up your refuge. It's too difficult to fix, and it's way easier to add a little bit twice than to try and take something out. And so you don't want it to get out of range on the hide side. So just add what you need. Reminder that any blending must be done by a accredited conditioner with an approved conditioner. And there are no pre-approved methods for refuge. It must be done uniformly. We've had seed growers use volumetric batch blenders for small volumes. They work great because you can control what you've got going in on both ends. We've had other members work with larger quantities that have set up two augers and trickled in over time and augered a few times, but they manage their flow rates. So both of those work, just as long as care and caution is used when adding the refuge, making sure that you're not adding too much. You're just adding what is required to meet the job. And the other part that does work well if you're doing own use on your own farm and need to add some refuge from a seed grower's perspective is to use 2 tanks on the drill and seed at a low level with the one into the other, and it works a great way of dispersing throughout the entire field. The problem with this is it's not going to provide a test that you're going to be able to certify that lot in until after harvest. So use that one with caution. That would only be for own use for a seed grower's level. Here's a screenshot of the refuge calculator. Just a few things. The green areas are what you would fill out. The percentage refuge is what would show up on your test. 1,000 kernel weight is important because you are measuring each kernel, and so if one is smaller than the other, you want to make sure you've got the equal number of kernels, not by pure volume. Germination is important, and then the lot size. This particular calculator says kilograms. As long as you're using the same units, you can use bushels, you can use tons, doesn't matter. It's going to spit out the same number. And the important thing to keep in mind here is if germinations are really out of whack, that makes me really nervous. If you've got two high germ lots that are both in the 90s, things are going to be okay. But we've seen samples in the past where we've got a seed lot that is maybe germing 75% due to high fusarium pressure to be blended with another lot, and we really don't know how that lower germ lot is going to react once it gets to the field. There's abnormals in there. There's if you treat the seed, the germ can come back. So it's a real wild card. So try to find two seed lots that are very close in germ, because it just makes the whole process that much gives you that much more confidence. So that's kind of the wrap on most of the material, but understanding the subtle differences between the two varieties that are in the blend can help you manage it in the field, help you protect it in the field, and then take it through the seed cleaning plant to try and minimize the amount of drift going forward. But it does take some extra work, and it's important that you share that information with your customers, because they're the ones that are ultimately benefiting, and you want to be talking about the value that you're providing to them. Last section here is talking about tagging and labels. And so when we talk about varietal blends, you'll often see two names. There's a marketing name that you'll see in field signs and promotional material, and then there's the official names. And if this wasn't confusing enough to have blends to begin with, but we've got two different ways of labeling them. So the marketing names can include the use of the varietal blend or trademark symbols like the AC with the R on them. Tags and crop certificates must use the official names that are as per the registration system within CFIA. And field signs, we can use the marketing names. And so I'm just going to show you the difference between the two. Here's a few samples. So the official name, to try and use that, would just confuse customers. And so we wanted to have a simple form, and fortunately CFIA was allowed us to do this back in the early days of midge tolerance, was to use the short form with the VB to indicate a varietal blend. So that tells the customer that something else is in that blend when it has the VB added to the end of it. When you look at the official names, that's what goes on bags, tags, to ensure that the certification process is working. And so in every one of those cases, both the tolerant variety and the refuge are listed. So as mentioned, there's more work for the seed grower, but it's an opportunity to show value. There's a lot of work that goes into this, and we want to make sure that it works. The new varieties that are coming, not only in different classes, so we have CWRS, we have special purpose, we have CPS, red now, and Durham. So across a wide range of classes, and we're starting to combine traits with short, strong straw, fusarium tolerance, and midge. So you don't have to choose one. You can get the complete protection package, which is fantastic work by our breeders. And so the protection's there when you need it. I had already talked about the sustainability of the system, the fact that it reduces reliance on insecticide. You're keeping the beneficial insects in balance. So it's been a great product to allow the sustainable production of wheat. And as mentioned, if we don't protect it, it could be broken down in as little as 10 years. And we want to make this last for generations. So stewardship helps us maintain that refuge. It helps it helps preserve the midge tolerance for the useful life and for future generations. And I just wanted to give a shout out here on my second last slide to Western Grains Research Foundation. Right from the very early days of the midge tolerant wheat work, WGRF has been providing all of the communication support for the program. And so the distributors, the developers have worked on the stewardship process and the database, but it's been WGRF that through producer checkoffs that's funded all of the communications over the last 9 years. So greatly appreciative of that. So 2 websites to jot down. One is midgetolerantwheat.ca. That is the one that has all of the information that you've seen. It has the videos, it's got background. That's where retailers would go to take training on midge tolerant wheat and ensure that they have all the information that they need to share with their midge tolerant customers. And the midge tolerant wheat stewardship assurance site is where a retailer goes to log in and enter their sales and have their customers sign their stewardship agreements. So make sure you've marked both of those ones down. The first one is the general background. That's the public site as well as the portal to midge tolerant wheat training. And then midge tolerant wheat, mtwsa.ca is the assurance site where we do the background. It's our evergreen stewardship assurance site. So that's all from me. I'll turn it back to Mark, and he can take questions.
Thank you so much, Todd. We'll now have a brief Q&A session before we wrap things up for today. If you have a question for Santosh or Todd, please type it into the chat box and just let us know which of our 2 speakers your question is directed to. Santosh, can you offer any insight on the 2019 wheat midge forecast, what we might be able to expect, especially on the prairies?
Yes, I can speculate. Midge levels were lower this year around Brandon and most of the prairies due to the hot, dry conditions in June and July. So there will be fewer flies going forward this year, so fewer eggs, fewer larvae, and fewer pupae. That doesn't mean that we can accurately forecast it for next year. Fewer flies that come up next year from the pupae can lead aggressively egg-laying process if the conditions are right, and there can be significant midge pressure next year depending upon how the season is. That's why scouting every year is important for predicting the forecast or predicting the levels that will affect the wheat crop. However, I can speculate that it will be a slow start for midge next year because we didn't see as many flies this year, if that makes sense.
Todd, can you recap for us, and maybe Santosh, you can add some comments as well if you wish. Can you recap for us the biggest threats to the midge-tolerant trait and the best way that we can mitigate them?
So for me, the biggest threat would be growing varieties repeatedly and not honoring the stewardship agreement, essentially. So if a variety was grown repeatedly and the refuge was to be mined out by midge over time, that would be the biggest risk. And so how do we mitigate that? It's really through continued communications of sharing the value of sharing the information of stewardship and why we do it with farmer customers. The response that we've had over the years of surveying past customers has been fabulous. We're 94% plus of them understand and appreciate what's being done and don't want to go back to the days where they were reliant on insecticides to control midge. So we've got a big fan base out there, and we just need to keep that message going.
Santosh, what is your research? Sorry, go ahead.
Yeah, I agree with Todd that that's the most critical step. I also want to mention that before the stewardship program came in, there may have been some varieties that were released and not tested for midge. So I think there is an active program going on where we are testing some older lines for their midge tolerance, and if they're found to be midge resistant and not labeled, then they are put into the system through the stewardship.
I'll just add to that one. Thank you, Santosh. Great point. Yes, there were there was one particular soft white variety that was identified after the fact to have SM1, and so it's always difficult to put the genie back in the bottle on that one. But we do have a communication program, and we're trying to work with seed growers have already remediated all of their future stocks of that variety, and we're working with farmer customers to communicate that that requirement through the producer commissions, as well as through a communications program to ensure that refuge gets added to that variety. And that one of concern is AC Santosh, the soft white variety that SeCan represents.
Santosh, what has your research revealed about new sources of resistance? Can you give us some more insight into that?
Our current research is involved in understanding the mechanism of wheat midge tolerance through oviposition deterrence, through the volatile compounds, as well as through the SM1-based resistance. The reason why we want to understand is that if we understand what kind of compounds are formed in either of the resistant mechanism, and if we can find another gene that is within the genome of wheat, we can use those or understand those and try to implement it in a better way in varieties that don't have SM1, so that we can have various different ways of combating this pest, not just one. And that's one of the active research that is going on. Right now, myself, Kurt McCartney out of AAFC Modern, Alejandro from University of Manitoba, and Tim in Saskatoon Research and Development Center, AAFC. We are collaborating together to understand all of these processes. There are different groups all across the world who are trying to understand what makes a variety susceptible, and if we can remove the susceptibility factor, then we can impart tolerance, and that's another mechanism of approaching this problem. So there are various different things going on right now. We don't have any successes yet, unfortunately, but we are actively working on this problem.
Todd, can you offer us some tips that retailers can use to help educate customers about midge tolerance and what they can do to preserve it?
So some of the easiest, one of the simplest things, if to explain it to a customer, is to use the videos that we've generated on midgetolerantwheat.ca. Right on the front page, there are 3 short videos. The 2 that I've shown, plus another one that's a little bit longer, tell the entire story. It well explained and gets the message across. If you're not familiar with the system, most of your questions could be answered there. There's also a retailer training. Anybody selling midge tolerant wheat can step through the midge tolerant wheat training. Takes about 20 minutes. Get your certificate online. Provides all of the background there in terms of the biology as well as the stewardship process, and is a great first step to understanding the package.
Well, that's all the time we have today. Thank you so much, everybody, for sharing a morning coffee with us, and I hope you found this information of value. And again, thank you so much to our sponsors, 2020 Seed Labs, SeCan, and Cantera Seeds, for their support. I'd also quickly like to thank our technical assistants, Kyle Dradawani and Teresa Kurdziewicz, who've been working behind the scenes to help make this a successful event today. Once again, this webinar will be available for viewing at germination.ca very soon, so please check our website for that. Thanks again, and we hope you have a terrific day. This is Mark Zinkowitz of Germination, signing off.